This is part 2 of the series Circumference and Area, and we're going to start off this part by discussing an alternative unit of measure for measuring angles, and that's going to be called the radian. Now up to this point we've been using degrees. A circle is 360 degrees, and we've been using angle measures from 0 to 360 degrees up to this point. But now we need to look at an alternate unit measure, and that's called the radian. Now the definition of a radian is it's the angle made by sweeping out an arc that is whose length is equal to the radius of the circle. So 1 radian is the measure of the central angle of a circle that sweeps out an arc with a length equal to the radius of the circle. So when you have an arc length of 1 and a radius of the circle of 1, that angle is 1 radian in measure. And as it turns out, it's about 57.3 degrees. Now, some of the advantages of using radians over degrees is the fact that, number 1, radians are smaller numbers, and number 2, radians are more directly related to the number pi. So I'd like to take a look at the derivation of the radian measure and show you the association with it. So what I'm going to do is I'm going to show you an arc length calculation, and we're going to use this circle with an arc length of 1, and the circle has a radius of 1. So here we have the arc length proportion. Arc length is to circumference as central angle is 360, and we have arc length, which is 1, over 2 pi r. Well, since the radius is 1, that's just 2 pi because r is equal to 1, so the 1 disappears. So it's 1 over 2 pi equals 1 radian, that's the central angle, divided by 360. Now, if we solve for radians, then we multiply both sides by 360, and we have 360 divided by 2 pi, or 1 radian is equal to 180 divided by pi degrees. The implication of this is if we take this equation and multiply both sides by pi, pi radians is equal to 180 degrees, and this one, 2 pi radians, is equal to 360 degrees. So you can see that with radians, the angles become much more closely related to pi, and they're much smaller numbers. Where we had 180 and 360, we have pi and 2 pi radians. So that's radian measure. Now, for the most part, we're still going to be continuing to use degree measure, but I wanted to make sure you understood the concept of radian measure, because you may hear it from time to time, and you will definitely use it as you go further on in your mathematical studies. One of the skills that we're definitely going to need is the ability to convert from radians to degrees and from degrees to radians. So let's take a look at how that's done. Now, since radians are a smaller number, an easy way to look at this is if I want to go from radians to degrees, I would take my radian measure, and I think about it like I have to make the number bigger somehow. So what I'm going to do is I'm going to multiply it by 180 and then divide by pi. So to convert from radians to degrees, my conversion factor is 180 divided by pi. So taking a radian measure and multiplying it by 180 over pi gives me degrees. And in the reverse direction, since degrees is a bigger number, I want to divide by the bigger number, 180. So to convert from degrees to radians, I'm going to multiply by pi divided by 180. So radians to degrees, the conversion factor is 180 over pi, and from degrees to radians, it's pi over 180. So let's do a couple of exercises just to practice this. So first, I want to try and convert pi over 4 radians to degrees. So I take my pi over 4, and it's radians, so it's a small number, so I want to make it bigger, so I'm going to multiply it by 180 over pi, and that will give me degrees. Well, if I look, pi divided by pi, these cancel out, and 180 divided by 4 is simply 45 degrees. So that was a fairly simple calculation. Didn't really even need to use a calculator for that. So let's try another one. Here we want to go in the other direction. We want to convert from 60 degrees to radians. So I take my 60 degrees, and I've got to make this smaller, so I'm going to multiply by pi over 180. Okay, so both of these have a common 10, so I can divide out the 10, and 6 divided by 6 is 1, so that's going to be pi, and 18 divided by 6 is 3. So 60 times pi over 180 comes out to pi over 3 radians. All right, let's take a look at another example. So here we're going to convert 2 pi over 3 radians, 2 degrees. So that's 2 pi over 3. And since it's radians, it's small, so I got to make it bigger, times 180 over pi. And again, these pi's are going to cancel out. And we can divide 180 by 3. That gives us 60. So 180 divided by 3 is 60. And 2 times 60 is 120 degrees. All right, let's move on to another example. This one says convert 180 degrees to radians. We've already said that 180 degrees is pi radians, but let's see how that works out. So we have 180 times pi divided by 180. 180s cancel out, and you have pi radians. And one final example. Here we're converting pi over 6 radians to degrees. So pi over 6, that's a small number, got to make it bigger. 180 over pi. Pi's cancel out. That's a 6, by the way. And 180 divided by 6 is 30 degrees. And that's how you do conversions. So now let's move on to the next topic, which is going to be area of a circle. Now I'm sure you've worked with area of a circle before. The area of a circle is the amount of surface covered by a circle. And here we have a circle with a radius r. And the formula is fairly straightforward. Area is pi times the radius squared. Now the most difficult thing with area is remembering which one is the area formula and which one is circumference. This is probably the #1 mistake that people make on these types of issues because they don't use it all the time. They sometimes forget. Now I had a student many years ago who told me a little story that was really silly, but it's usually the silly things that work. If this works for you, great. If not, then just come up with some mechanism to allow you to memorize the area of a circle formula. But the student said, hey, you know how you go to McDonald's and you can get an apple pie, and you know how the apple pies aren't round, but they're kind of squarish? And I said, yeah. And so she held up her hands in front of her in the shape of a rectangular shape, and she says, well, look, the area of McDonald's pies are squared. Get it? And I looked and I said, okay, that's kind of cute. So the area of McDonald's pies are squared because McDonald's pies are squared. Anyway, that's an interesting little thing. If you don't like it, don't use it, but if it helps, great. So that's as simple as that gets. Let's try a couple of examples and see if we can get this down. In our first example, we want to find the area of a circle with a radius of 3. So area is pi r squared. That's supposed to be a pi, which is pi 3 squared, which is approximately 28.3. So that's the area of that circle with a radius of 3, approximately. Let's work another one. So here we want to find the area of a circle with a circumference of 6. So we don't have the radius. We're going to have to use the circumference to find the radius. So we know that circumference is 2 pi r, and since 6 equals 2 pi r, that means our radius is going to be equal to 6 divided by 2 pi. And that's going to be approximately 0.955. Now, we would not want to use this number, obviously. We would want to use the number stored in our calculator because we're going to lose a lot of precision in the rounding. So I want to use this number, but I'm just going to write this just for the sake of the problem. And let's go ahead and calculate our area using that number. So our area is going to be pi r squared. And I'm not going to use this 0.955. I'm going to use the number that I stored in my calculator. So this is going to come out to approximately 2.9. All right, and one final example. So in this problem, we're given the area is 12.4 inches. We want to find the radius. So area equals pi r squared. 12.4 equals pi r squared. We're going to divide by pi. So that's 12.4 divided by pi equals r squared. To solve for r, we're going to take the square root of both sides. And so therefore r is going to be approximately equal to this number, the square root of 12.4 divided by pi. And notice that I'm putting the calculation over here instead of doing intermediate results. That is, I'm not dividing 12.4 divided by pi and then writing that down and then taking the square root of that number. I don't want to do that because I don't want to lose precision. I'm going to regularly show the calculation like this and put the calculation in at the end at one time in the calculator. Calculator is just a calculating tool. I'm not going to use it as a thought tool. So the answer comes out to 1.987, or you could round to 2. All right. Well, that covers areas of circles. Now, in the next session, we're going to start a new topic that's very closely related to arc length, and that's going to be the area of a sector of a circle. But we're going to do that in the next session, so I will talk to you in the next video.